sun's very important. So why do we want to study the sun? Okay, as I said, life on Earth is basically governed by the sun. But there's other things that happen too. And that is that the sun occasionally burps out stuff we call coronal mass ejection, a big giant plasma material that flies across the solar system and slams into Earth's magnetosphere. That causes variation in the Earth's magnetic field, what we call geomagnetic storms. It can also affect communication. It has knocked out communication now and then. It's interfered with guidance systems of aircraft and ships. It's also knocked out GPS signals. It's knocked out satellite communications. Cell phones have sometimes been having issues. All kinds of things have had issues during these sort of events. These solar storms also produce blast of radiation that can affect air travel. They have radiation storms that are associated with this as well. All this stuff, the radiation effects, the radio blackouts, and the geomagnetic effects are all collectively referred to officially as space weather. And so it's monitored as space weather. A number of years ago, there was actually a major geomagnetic event, major radiation storm, and any transatlantic flight at the time received a couple hundred chest x-rays worth of radiation over the course of the flight. And so it was enough radiation exposure that they actually held flights on the ground, both in North America and in Europe, for a period of time. Now, they didn't tell the passengers directly that we're not taking off because there's too much radiation. They just said it's a weather-related delay, and technically they are exactly correct because that is all officially called space weather. And so there's a sun is constantly monitored. There are ground stations monitoring the sun all over the earth, monitoring the sun continually 24/7, 365 days a year. There's a constellation of satellites orbiting Earth and in in space outside of Earth's orbit, always monitoring the sun. The sun is constantly monitored because of the possibility of all these kinds of things that might happen. But the sun affects Earth in a lot of subtle ways. Very small variations in the sun have been keyed to certain climatological changes, weather changes, all kinds of things. So the sun really can affect the Earth in a lot of ways. So we really want to study it. As I said, these blasts of material coming out of the sun, slamming into Earth's magnetic field, you can create the aurora, create geomagnetic storms, all kind of events. These are the dramatic things. But there's all kind of other things that do this as well. I like to direct people to a website called spaceweather.com. And spaceweather.com is a fantastic website to keep track of what is the sun doing. And so it's a great great site to go look at. They often have, if you look at the last live lecture I did, you'll notice that I said some things here about it. It keeps track of space weather, but it also keeps track of radiation events of the sun, possibility of solar storms, other sort of things, aurora, things like that. But other just it's people that watch the sun also just look at the sky, so you have a lot of astronomers too. So they'll have some information in there about comets you can see, near Earth asteroids, near misses by things, meteors, all kind of sky events that you can see. It even has a list of which commercial airliners, air flights have had the most radiation exposure in the last 24 hours, something like that. So in case you're interested in that. So there's all kind of interesting information. Spaceweather.com. Be a great place to go to just keep track of things. If you're really interested in looking at the aurora, It's very rare this far south, but it sometimes happens. Not very often is it going to happen when the sun is blank like it is right now. But when the sun's more active, you sometimes can, and you can actually sign up for email notices of geomagnetic storms or events, or of space weather events, or of aurora sightings and so forth. So let you know when to go out and look. Basic information of the sun. How far away is it? 1 AU. Well, duh, by definition. The Earth orbits 1 AU from the sun. That's about 8 1/3 light minutes away. And so at that distance, even though the sun's really big, then that is about 32 arc minutes in diameter, which is actually small enough. If you hold your hand out with your pinky extended, the tip of your pinky would cover the sun. So just think about that. Close one eye, and the tip of your pinky at arm's length would just barely cover the sun. So that's really not that big in the sky. It seems a lot bigger than it really is in the sky because it's so bright. At 1 AU from the sun, the solar constant, which is the power per area, or the energy per time per area, is 1,400 watts per square meter. That's 1.4 kilowatts per square meter. That would be roughly 300 times brighter than a roughly 60-watt old incandescent 60-watt bulb located 1 meter in front of you. Sun is perfectly round, almost. Oblateness, how far out around it is? It's 9 parts out of a million out of round. So about 1 part, almost, it's less than 1 part in 100,000 difference, wider at the equator than pole to pole. Now, when the sun's setting near the horizon, it has this sort of flattened look to it, and the flattened look here is entirely due to the atmosphere. And so you sometimes will notice the sun's rising and setting, it looks much wider than it is tall, and that's the atmospheric effect. Physical data. The sun is about almost 700,000 kilometers radius. So that means about a million miles all the way across. That's over 100 times the radius of the Earth. So that means you could fit over a million, about 1.3 million Earths inside of the sun. It only weighs about 333,000 times how much the Earth weighs, though. So what's the difference here? Well, the difference is the sun's made of lighter stuff, mostly hydrogen and helium. So it has a density of about 1.4 grams per cubic centimeter. Well, hydrogen and helium are a gas. They are normally not very dense at all, so you can imagine just how dense it has to be, how compressed it has to be, so the average density of the sun is actually that high. Total wattage, this is this is like the wattage of the sun. The luminosity is the wattage. Most every textbook is going to give you this, what I think is a stupid number, and that is the surface gravity of the sun. The sun has no surface. It's a gas. There's no solid surface here. You know, you just, as you get into it, there's actually stuff up here that's super thin, that's just not shining very bright, and then you get to the part that's shining real bright, and you keep going deeper, and there's never really a surface in there. So it's really silly to talk about surface gravity, but typically if you were at a spot that was about right here on the sun compared to the center, then that would be about 274 meter per second squared. For Earth, it's 9.8 meter per second squared, so that's about 28 times the force of gravity on Earth. The spectrum of the sun. The light-colored squiggly sort of thing there is the actual measured spectrum of the sun. The gray in the background is the actual black body spectrum for something that's about 5777 Kelvin. So that would be the black body. So we'd say the sun's really close to 5800 Kelvin. It's not a perfect black body, but it is really darn close. Okay, so what color is that? 57, whatever, that's about 5800. That means it's about 500 nanometers. What does 500 nanometers look like? Well, it looks like that color right there. Now, to me, that looks kind of a yellowish green color. A lot of textbooks refer to the sun as a yellow star. It's not yellow, it's this greenish color. And that green color right there, I got a couple of friends that refer to the sun as the big green thing in the sky. But that's the peak output of the sun. And so that being the peak output of the sun, then that is that's why plants are green, for one thing. And your eye is most sensitive to that color, peak output of the sun. And for a number of years ago, actually the city of Hearst painted their fire trucks kind of a slightly more yellow version of that, kind of a yellow-green color, and because that's the most visible color possible. And the only thing is that people weren't yielding to them because they didn't recognize it as a fire truck. I mean, you think of fire trucks as being mostly red or white or something, but you don't think of them as being kind of a yellow-green color. But yellowish or yellow-green actually is sometimes the color that crash tenders are painted at airports because it's such a visible color. The sun doesn't give off just one color, though. The sun is not giving off just that one color right in here. The sun gives off all of the different colors. When you put them all together, then this is the color that you see, which is very close to white. And so, so that's really the color that your eye sees when you look at the sun, and that's because it's really a combination of all of the spectrum of the sun. So we talked about this before. What's the sun made out of? Hydrogen and helium. Well, some books say the sun is 74% hydrogen, and some books say the sun is 92% hydrogen. What's the difference? Well, it depends if you're going by mass or by number of atoms. I like to go by number of atoms, and I say the sun is 92% hydrogen. So over 9 out of 10 atoms in the sun are hydrogen atoms. Almost 8% of the sun is helium, and 0.1% are those metals. That's anything other than hydrogen and helium. Okay, now by weight, about a quarter of the sun is helium. Helium weighs 4 times what hydrogen does. And so even though it makes up only about 8% of the sun, it weighs about the sun is about 25% helium by weight and 74% by hydrogen. Okay. In the galaxy, the sun is roughly 8,000 parsecs. That's about 26,000 light years from the center of the galaxy. We orbit the galaxy at about the sun orbits around the galaxy about 220 kilometers per second. It means it takes about 220 million years to make one orbit. We call that distance, that time right here, the time it takes to make one orbit around the sun, a galactic year.